Hello, good evening guys. What's up? What will be discussed today is all about atoms, subatomic particles, proton, neutrons, and electrons, information about them, atomic number, mass number, and isotopes. And how we're going to compute for proton, neutrons, and electrons, atomic numbers, and um, the mass number. Okay, so let us first start with the recall about atom. Last time I talked about atom. So this is the smallest part of an element. Okay, so that can take part in a chemical reaction is described as atom. Atoms consist of small, dense molecules, okay, made up of neutrons, which doesn't have charge, and positively charged proton, and lastly for the negatively charged electrons in a cloud around this nucleus. Okay, last time we talked about some of the materials used for studying the composition of atoms. We have so many, and one of these is synchrotron. Synchrotron. Okay, a machine. This is a machine or huge powerful machine used to study composition of atoms. So let us use first in an illustration. Okay, so we have an atom and its part. Okay, so let's have P, N, positively charged, proton, negatively charged, so zero charge, neutron, and negatively charged electron. So we have here known as proton, and for this one is neutron, and for the last one is electron. Okay, so this is a parts of an atom. Okay, so the whole atom has no charge because there are so many, or are as many protons as there are electrons. So the charges balances each other out. Okay, although protons and electrons have opposite charges, which is this one. Okay, so proton positive does not attract electron negative right into the nucleus here. So because of its speed, okay, so it keeps them flying away of the nucleus. The pull of the nucleus keeps or these electrons in their orbit so that the atom does not lose them. Okay, so let us move for the next one. Okay, so my question is, the first question, how do we explain why why proton with a positively charged, okay, does not attract electron with negatively charged or negative charge right into the nucleus. Excuse me. Okay, so maybe you can remember the answer. So I've mentioned it earlier. Okay, so let us move. Okay, so let us first discuss the electron, one of the parts. So in year 1897, Sir J.J. Thomson discovered that the electron as a result of his investigation of the flow of electricity through an evacuated glass tube. So he discovered that an electron has mass. So the mass of electron is equivalent to 9.107 times 10 raised to negative 28 power, which is the grams. And its equivalence is 5.486 times 10 raised to the 4th power AMU. So what is AMU? So you might ask me, what is AMU, an acronym AMU? So the meaning for AMU is atomic mass unit. Let's write it here. Atomic mass unit. Okay, so we have the meaning for its acronym. Okay, so let us move now to the next. So aside from AMU, its diameter of an electron is equivalent to 2.818 times 10 raised to negative 13 centimeter. Okay, and its equivalence to angstrom is 2.818 times 10 raised to negative 5 which is means angstrom. Okay, this is a very small unit, which is equal to 100 to 100 millionth of centimeter. Okay, that's a very small unit. Okay, so let us move. So in year 1913, Niels Bohr, or Niels Henrik David Bohr a Danish physicist, suggested that the electron of an atom is moving in a simpler circular orbit or shell around the nucleus. They are designated as KLMN, KLMN, and so on. Each cell carries a number of electrons. Okay, so let us have illustration of what he said. Okay, so we have here P and N, P and N. Now, so 2, 3, 4, 5, 6, 7, 8. Let's have 8 lines. 2, 3, 4, 5, 6, 7, 8. Oops. Now let us bend this first. Let us bend these lines accordingly. Let's make a hole. Okay, so let us name them alphabetically arranged. We have K, L, M, N, O, P, Q, R, and these are shell. They are all shells. So on and so forth. Okay, so each of these letters carries numbers of electrons. So we have 2 electrons here, and it's ascending to 8. And we have for M, which is 18 electrons and 32 electrons, and same number with N shell, 32. We have 18 descending to 18, 8 electrons, and lastly for 2 electrons. Okay, so let us move now to the next. Okay, so next part with next subatomic particle will be the proton. So the proton number determines the chemical properties of the element because of the electron structure, which determines chemical bonding, depends on the electrostatic attraction to the positively charged nucleus. Okay, so in year 1886, Eugene Goldstein Goldstein discovered that the proton, during investigation of positive rays which appear when electricity flows through specially designated evacuated glass tubes. Okay, so of course he made a discovery about its mass. The proton has mass too. So mass of proton is equal to 1.672 times 10 raised to negative 24 grams, and it's equivalent to 1 AMU, atomic mass unit. And for the diameter of proton is 10 raised to negative 5 angstrom unit. Okay. Next, let's proceed to the next. Okay, so how about The last one, neutron. Okay, so neutron here. A neutron is a particle found in the nuclei. This can be found in the nuclei. Okay, nuclei of all atoms except that of hydrogen. Okay, this is a neutral particle, has about the same mass as proton. Okay, with the discovery of neutron in year 1932 by James Chadwick. Chemists were able to account for the main feature of atoms in terms of three fundamental particles, which are proton, neutron, and electron. Okay. Neutron or neutrons do not contribute to the number of positive charge in the nucleus because they are neutral. Okay, so neutrons account only for the difference between the atomic mass and atomic number. Of course, neutron has mass also, which is the same mass as proton. Okay, so we have the mass, its mass is equal to 1.675 times 10 raised to negative 24 grams, which is equivalent to 1 AMU. Okay, so as you can see, they have almost the same mass of that proton. Okay, so let us move now to the next. Okay, so let's move to atomic number and mass number. Let us first discuss the atomic number. All atoms are electrically neutral and must therefore contain the same number of protons, the positive charge, as electrons, the negative charge. We have here atomic number. Which is Z. Okay, the atomic or the number of protons in the nucleus of an atom is called atomic number. So it means the number of protons, okay, is equals to atomic number. Okay, the fact that the proton was found to be about 1,837 times as heavy as electrons, okay, supported by Rutherford. Rutherford's theory of nuclear atom. The light electrons could, at relatively great distances, surround the nucleus, okay, that might be made of heavy positive protons collected together. Hendrik Wien or Hendrik Wien Jeffrey Moseley. Okay, Moseley discovered that the various elements emitted characteristic X-ray when bombarded with fast-moving electrons. Okay, so let us draw the X-ray. Okay, so which is the tube. Let us have this first. Okay, let us first have a line here. Okay. Let us color this one with black, and let us have electrons which are fast moving. Okay, we have E here. Electrons. Wow, which is fast moving. Okay, and this, I'm sorry. So as we are seeing electrons with its high speed. Okay, so there is, wait, okay, we have here an X-ray or X-rays. Okay, so an X-ray tube, when bombarded with fast-moving electrons, okay, mostly found out that the wavelengths of X-ray emitted decreased regularly as atomic weights of the elements increased. So he was able to state that the number of positive charge of the nucleus increases from atom to atom by single electronic unit. This number of positive charges is now called as atomic number and is 1 hydrogen, 2 for helium, and 3 for lithium, etc. So on and so forth. So it means if we have number of protons here, let's say we have 1 proton, okay, it's equals to 1 atomic number, and it's equals to 1 electron. Okay, did you get it? So let us move now. Wait, where's my notes? Okay, next, mass number. The next one is mass number. We're done with the atomic number, and we have here now mass number, which is A. Okay, the sum of the mass, or the sum of the number of protons and neutrons in the nucleus of an atom is the mass number. So sum here, sum of the number of protons and neutrons in the nucleus is called the mass number. Okay, so the sum of the number of protons and neutrons in the nucleus is called the mass number. Most of the mass of an atom is concentrated in the nucleus. Since it contains the neutrons and protons and electrons are only 1 over 1,837 the mass number or the mass of either of these nuclear particles. The amount of total mass of an atom contributed by the nucleus varies from 99.95% or percentage. So we have 99.95%, which is a light atom. To 99.98% heavy atom. Atomic masses are measured using mass spectrograph. Okay, so atomic masses, let's write it first. Atomic masses are measured using mass spectrograph. Okay, so where are we now? Mass spectrograph. Okay, so this device was developed by F.W. Astron, an English scientist. Excuse me. In year 1919. Okay, the atomic masses of elements are not whole numbers because atomic mass value are average atomic masses of very great number of atoms. Okay, so where are we now? Because the atomic mass value are the average atomic masses of a very great number of atoms of an element, which is more one isotope. So isotope. So if, for example, an element has a mass of 18 AMU, atomic mass unit, and another element has 19 AMU, another is 19 AMU, okay, in a mixture of both isotope, an equal number of atoms of each isotope is present. So the average atomic mass of the element is 50% of 18. So let's